everyone, I am Haiying Che from Institute of Data Science and Knowledge Engineering, School of Computer Science in Beijing Institute of Technology. In this session, we discuss about NoSQL database core concept, CAP theorem, and NoSQL database transaction model, BASE, B-A-S-E. The big data computing system can be summarized into three categories: data storing system, data processing system, data application system. Here we're still in the scope of data storing system. In data storing system, there are four parts to accomplish different tasks, which is data collection and modeling, distributed file system, distributed database data warehouse, and unified data access interface. Here we still in NoSQL database. In NoSQL database, there are two important concepts: CAP theorem and NoSQL database transaction model, BASE, B-A-S-E. Let's look at the CAP theorem first. CAP theorem means a distributed system cannot meet three requirements of consistency, availability, and partition tolerance at the same time. At most, only two of them can be satisfied at the same time. C stands for consistency, which means even in a distributed environment, the data of multiple storage nodes have the same data value at the same time, and all data backup updates should be synchronized. A in CAP here stands for availability, which means client can quickly read data, return operation results within a reasonable time, and ensure that every request has a response, regardless of success or failure. P in CAP stands for partition tolerance, which means that when a partition in the system cannot communicate with other nodes, it does not affect the normal operation of the rest of the system, or the error or loss of part of the system data does not affect the overall operation of the system. According to CAP theorem, a distributed system can only meet two of the CAP in the middle run data read and write operations, but not three at the same time. The choice of CAP also leads to the difference between relational database and NoSQL database. Okay, let's watch a video about CAP theorem.
So what is the CAP theorem truly? It's a simple statement. A system can only have two out of these three properties at any given time. The choice must be made between consistency, availability, and partition tolerance. You see this intersection of these three right here? This is what we like to call a magical fantasy land. Decades ago, when distributed systems were still new in academia, several researchers and organizations claimed that they had created systems which had all three properties. We'll give you a quick proof in just a few seconds as to why CAP theorem is true. In order to prove the CAP theorem, let's run through some examples. In each example, we're going to be giving an example of a situation in which choosing two properties forces us to yield the third. Let's pretend this is a database which stores my favorite color. In our first example, let's choose partition tolerance and availability. Here's how we lose consistency. Let's say it's the end of my senior year. I'm graduating from Berkeley, but I get accepted into a graduate program at Stanford. Naturally, my favorite color will have changed from blue to red. I send the update to the system, and my message happens to go to Node 1. Node 1 relays the update to all other accessible nodes, which update their state. Node 2 and 4, however, cannot receive messages from the other half, so they're not aware of the update. I later query node 2 for my favorite color. Node 2, according to our choice of availability, will return its current state. However, this is not the most recent state, as the most recent update was red. Because node 2 provided a state that was not the most recent, it was not consistent. Let's try another configuration, particularly partition tolerance and consistency. We'll see how that ends up sacrificing availability. So same scenario. I send the update to node 1, which then sends the update to all the other nodes. Nodes 2 and 4 are still ignorant of the update to red. Again, I query node 2. So what happens this time? Since node 2 is bound to consistency, it chooses not to return anything. The bad news is we get no information, but the good news is we get no outdated information. If you're wondering how node 2 knows it's outdated, we can say that it first asks all other nodes for updates before returning a state. If it cannot receive messages from all nodes, it will assume it has outdated information and refuse to return a value. We lose out on something in the last two examples, so let's see what happens when we choose consistency and availability. I send an update to node 1. Node 1 passes the information around. I query node 2 and it returns a value to me. Great, everything worked as expected, except there's one problem. If we throw in a partition, this wouldn't work. If we throw in a partition, we're forced into one of the first two situations. And this proof demonstrates the spirit of the CAP theorem, that a system must compromise.
From the video, we understand why the CAP, consistency, availability, and partition tolerance can't be satisfied at the same time. The diagram here shows different product choose different combination of C, A, and P. Traditional relational database choose C and A, which means consistency and availability. This is to emphasize consistency and availability, but give up partition tolerance. The simplest way is to put all transaction-related content on the same machine. Obviously, this approach will seriously affect the scalability of the system. Traditional relational database, like MySQL, SQL Server, all adopt this design principle, so they have poor scalability. MongoDB, HBase, and Redis choose C and P. This is to emphasize consistency and partition tolerance, but give up availability. When the network partition situation occurs, the affected service needs to wait for the data to be consistent, so they cannot provide a service to outside parties. And CoachDB, Cassandra, etc., they choose A and P. That is to emphasize availability and partition tolerance, but give up consistency, which allow the system to return inconsistent data. Now let's learn the NoSQL characters BASE, base. Base means basically available, soft state, eventual consistency. Speaking of base, I have to talk about ACID. A database transaction has 4 ACID properties. A stands for atomicity. Atomicity means that the transaction must be an atomic unit of work. For data modification, either all or none of them are performed. C. Consistency. Consistency means that when the transaction is completed, all data must be kept in a consistent state. I here means isolation. Isolation means that changes made by concurrent firms must be isolated from changes made by other concurrent firms. D in ACID means durability, also means persistence. Persistence means that after the transaction is completed, its impact on the system is permanent. This modification will be maintained even if a fatal system failure occurs. The basic meaning of base is basically available solved state and eventually consistency. And basically available means that when a part of a distributed system becomes unavailable due to a problem, the other part can still be used normally. This is the situation where the partition fails. Soft state. Soft state is a term corresponding to hard state. When the data stored in the database is hard state, data consistency can be guaranteed. That is, the data is always correct. But soft state means that the state can be out of sync for a period of time with a certain lag. Eventual consistency means subsequent access operations temporarily can fail to read the updated data, but after a period, the updated data must eventually be read. According to whether the subsequent operations can obtain the latest data and a high concurrency data access operation, the types of consistency include strong consistency and weak consistency. The main difference between the two, strong consistency and weak consistency, is whether the subsequent operation can obtain the latest data under high concurrency data access operation. For strong consistency, after performing an update operation, other subsequent read operation can ensure that the latest updated data is read. Otherwise, if it cannot be guaranteed that all subsequent reads will read the latest updated data, then it is just weak consistency. And eventual consistency is just a special case of weak consistency, allowing subsequent access operations to temporarily fail to read the updated data. But after a period of time, the updated data must eventually be read. In this session, we learned two important concepts, CAP theorem and NoSQL database transaction model, BASE, which is basically available, soft state, eventual consistency. Thank you for your attention. If you have any question, feel free to contact me.